Hey everyone, welcome back to the channel. Today we're taking a deep dive into one of the most intriguing and forward-looking aerospace developments in recent years, Grumman's YFQ-48A fighter, a semi-autonomous unmanned combat aircraft prototype recently designated by the United States Air Force as part of its Collaborative Combat Aircraft Program, an initiative aimed at integrating advanced autonomous systems alongside crewed fighter jets to revolutionize air combat. Officially known as the Mission Design Series YFQ-48A, this aircraft emerged from the industrial research project formerly called Project Talon, a design developed by Northrop Grumman in partnership with its subsidiaries Scaled Composites, as a potential next-generation combat drone capable of operating in contested environments and teaming with human pilots to extend the reach, survivability, and striking power of the overall air fleet. The designation itself is significant. Under Pentagon naming conventions, the letter Y identifies the aircraft as a prototype, F indicates a fighter role, and Q shows it is uncrewed, reflecting a fundamental shift in how modern militaries are redefining the concept of the fighter aircraft in an age of autonomous systems and manned-unmanned teaming. Unlike earlier uncrewed aerial vehicles that primarily focused on reconnaissance or light strike roles, the YFQ-48A is designed from the outset to serve as a semi-autonomous combat asset, capable of performing a range of missions that extend from coordinated air-to-air and air-to-ground operations to electronic warfare support and intelligence gathering, all while integrated into a broader networked battle space. Under the Air Force's Collaborative Combat Aircraft Program, these types of autonomous platforms are intended to work in concert with manned fighters, such as the F-35 Lightning and future sixth-generation air dominance aircraft, providing what strategists refer to as loyal wingman capabilities, machines that can fly ahead, draw enemy fire, gather sensor data, and even execute kinetic effects on targets while protecting human pilots from direct exposure to danger. At its core, the YFQ-48A is built around an airframe optimized for reduced observability, advanced avionics, and AI-driven autonomy. While many specific specifications remain classified due to the prototype nature of the program, what is publicly known indicates that the aircraft employs a hybrid composite metal airframe with features designed to minimize radar cross-section and thermal signature, enhancing its ability to operate in contested and denied airspace without immediately revealing its presence to adversary sensors. The airframe likely incorporates swept or lambda wings and discrete control surfaces that balance aerodynamic efficiency with stealth requirements, ensuring it can maneuver effectively at a broad range of speeds while sharing sensor data and mission status with networked platforms via secure communication links. One of the most notable aspects of the YFQ-48A's design is its artificial intelligence and autonomy stack, which represents a major advance over earlier drone systems. Rather than requiring direct control inputs for every maneuver, the aircraft uses a combination of onboard AI processors, machine learning algorithms, and sensor fusion to assess the surrounding environment, maintain formation with crewed aircraft, execute mission tasking, and respond dynamically to evolving threats. This level of autonomy allows it to fly complex missions with far less human input, enabling operators to focus on mission objectives instead of micromanaging flight controls. It also supports collaborative mission execution, where multiple autonomous drones and manned fighters coordinate in real time, sharing targets, threats, and tactical recommendations in a way that expands combat mass without proportionally increasing human workload. The YFQ-48A's designation as a prototype within the Air Force's CCA program came in December of 2025, marking a key milestone in its development and acknowledging that the design has achieved a level of maturity that merits official recognition and continued evaluation. The Air Force described the platform as a strong contender for future CCA fleets, emphasizing its role as part of a broader push towards semi-autonomous combat aircraft that can augment human pilots rather than merely operate as remote-control drones. This shift reflects a growing recognition that future air combat will rely not solely on advanced fighters, but also on scalable, networked autonomous systems that can fill roles ranging from persistent surveillance and long-range strike to electronic warfare and decoy operations, all while reducing risk to air crews and increasing operational flexibility. Integral to the YFQ-48A's mission concept is its modular payload architecture, which allows it to carry a variety of sensors, communications packages, and potentially weapon systems depending on mission requirements. Although Northrop Grumman and the Air Force have not publicly confirmed specific weapon loads for the prototype, analogous collaborative combat aircraft designs are expected to carry air-to-air missiles, air-to-ground precision munitions, electronic warfare pods, or advanced sensor suites that feed real-time data back to both manned fighters and ground control stations. In a contested environment, this payload flexibility enables the YFQ-48A to adapt rapidly to diverse mission sets, transitioning from reconnaissance to targeting to strike applications without requiring a change of platform or extensive reconfiguration between flights. Another critical dimension of the YFQ-48A is its role in manned-unmanned teaming. Rather than operating independently of human decision-makers, the aircraft is designed to complement crewed platforms, serving as an autonomous wingman that increases the situational awareness and firepower of piloted aircraft. In practice, this means that a pilot in a conventional fighter could task the YFQ-48A to scout ahead, identify threats, relay encrypted sensor data back to the team, and even engage targets in coordination with human-piloted assets. This cooperative engagement model not only expands the tactical envelope of a strike package, but also complicates adversary defense planning, as opponents must now contend with swarms or pairs of autonomous fighters working in concert with human air crews. Strategically, the designation of YFQ-48A underscores the Air Force's enduring focus on agile, scalable force structures that can operate effectively across a wide range of conflict scenarios, from high-end peer contest environments to more distributed, multi-domain operations, by investing in autonomous aircraft that can act as force multipliers. The service is betting that the future of air power will not be defined solely by the most advanced crewed fighters, but by the networked integration of manned and unmanned systems that leverage artificial intelligence to deliver effects with speed, precision, and resilience. If these prototypes ultimately enter production and deployment, they could reshape how air campaigns are planned and executed, giving commanders the ability to mass sensors and strike assets without increasing risk to human life. And that brings us to the end of today's detailed look at Grumman's YFQ-48A fighter, a cutting-edge example of the future of autonomous combat aviation. If you enjoyed this deep dive, make sure to hit that like button, share this video with your aerospace and defense crew, and subscribe to the channel for more deep dives into next-generation platforms shaping the future of warfare and flight. Drop your thoughts in the comments below. How do you think unmanned fighters like this will change air combat? Thanks for watching, and I'll see you in the next one.